Let's start. So this is about coordinate geometry and straight line. So first of all, let's do coordinate geometry. We have to revise that one before doing straight line. So anyway, straight line circles, very important section. So you consider first coordinate geometry. Coordinate geometry. Okay, here you consider x-axis, y-axis. Here point P, we say x comma y, x comma y. Here x coordinate, ordinate, y coordinate, ordinate, x coordinate abscissa. Y coordinate, ordinate, x coordinate we say abscissa. Then here this angle from the positive direction of the x-axis we say theta inclination. Inclination. Then tan theta we call gradient. Inclination and gradient. Then here consider O, P, here this coordinate x, here this coordinate y, and here this length we say y modulus. Modulus represent length. Coordinate can be positive or negative, but here this one we say y modulus, here this one we say x modulus. X modulus. Then if you need to find OP distance you apply Pythagorean theorem. Here modulus x squared plus modulus y square root, no? Then finally we write x squared plus y square root. Here OP distance. Then MOP we say gradient of OP line segment, that is y divided by x. We call y divided by x. Y divided by x. Here length of OP and here gradient of OP. Gradient of OP. So here this is first theorem. Okay, I'm going to revise this one, but anyway you just write this on coordinate geometry. I have given a tutorial. So you have, I think you have space to write there. Here page number 3 contains space, you better write there. Otherwise you write in your notebook. Distance formula, right there. Here coordinate geometry. In that space you just write this one. So I need to write another one section. So one half you take to write this one, the other half we have to write another thing. Okay. Okay. Let's do that one as well. Okay. See further. I'll do that one as well. Now here second case. Here you take x and y axis. Here point P, x1, y1, point Q, x2, y2. Then here x2, here x1, here x2 minus x1 modulus. Here y1, y2. Here y1 minus y2 modulus. Then PQ distance we write x difference square, x1 x2 minus x1 modulus square, y1 minus y2 modulus square root. Here this is distance formula, distance between 2 points, x2 minus x1, y2 minus y1 square root. Then MPQ we write y2 minus y1 over x2 minus x1, y difference of x difference, or here I have started with second coordinate now, then you can start with first coordinate as well. y1 minus y2 over x1 minus x2. Okay, write them all in that space. section that space and write here this one first. Then you write this same space. Okay, question set 1, continue. Question set 1, continue. First one, find the length of the line joining of two pair of points. 2 points are given, then by that one you find distance formula. You better practice this simplification. 3 squared plus 4 square root 5, 5 square plus 12 square 13, Pythagorean triple. Then a square plus a square root, we say a square times 1 plus 1, we say here modulus a root 2. Then here a square plus 2a square order, you can take a square outside, 1 plus 4, 5, root 5. Then you have applied distance formula. Continue. Then question number 2, we have to find gradient. So gradient means y difference of x difference. 1 minus 4 over 0 minus 3. 1. Here it doesn't have any unit. Then 5 minus 9 over minus 2 minus 5. Then here minus 2. Third, 1 minus 11 over 3 minus 8, 2. Fourth, 3 minus 7 over minus 6 minus 3. Minus 6 minus 3. 3 minus 7 over minus 6 minus 3. Here minus 4 or minus 4, 1. Gradient. Apply directly previous theorems, distance formula and gradient relation. Gradient means y difference of x difference. Okay, then question number 3. So 2 points are given. Find the angle. We have to find angle. Here this is gradient, okay? By gradient we can extract angle, no? With the positive direction of the x-axis. Then here you consider here angle theta. Then gradient m equal tan theta, no? Then theta equal tan inverse m. Tan inverse m. Then you write tan inverse angle theta equal tan inverse y difference of x difference. Minus 1 minus 2 over minus 1 minus 2. Here tan inverse 1 equal pi divided by 4, no? Angle pi divided by 4. Continue. Question number 4. Find the angle made by the line joining of two pair of points with the positive direction of the x-axis. Then you say theta equal tan inverse m, no? Tan inverse m. M mean minus 2 minus 7. Minus 2 minus 7 over 5 minus 4. Then tan inverse 9 over 9 minus 1. 9 over 9. Okay, then here 135. 3 pi divided by 4. 3 pi divided by 4. Continue. Question number 5. The coordinates of the vertices of quadrilateral given A, B, C, D. So we have to find length. So first of all, let's mark coordinates in coordinates plane. So if you have more than 3 coordinates, you better to mark on coordinate plane. So you mark them here, x-axis, y-axis. If you have 2 coordinates, if you have 3 coordinates, no need to get coordinate plane. But if you have more than 3 coordinates, you mark them on Cartesian plane. Here 1, 2, 1, 2. Say A. Second one 4, 5, 4, 5. Say B. Next -1, 3, -1, 3. Say C. And 2, 5. Here 2, 5. Say D. Then sketch quadrilateral. So by that order, we get this type of quadrilateral. Okay. Then here AB length, x difference square 1 minus 4 square, y difference 2 minus 5 square root, no? Here 3 square, 3 square, 3 root 2 units. So when you write distance, you have to put units, no? Then here units are not given, therefore you have to take any unit. No? Then that is AB. Then BD. BD we can easily write because y coordinate 5, then 2 units. Here 2, 4, difference 2. Then CD. CD. Here -1, -2 squared, x difference square plus y difference, 3 minus 5 square root. Here 3 square, 2 square, 9, 13. Root 13 unit. CD AC. -1 squared, 3 minus 2 square root. Here 2 square, 1 square, root 5 units. Those are the sides. Those are the sides. Continue. Continue. Question number 6. Same type question. X-axis, y-axis, 3, 1 coordinate first. 1, 2, 3, 1. 3, 1. B 1, 3. C1 comma 5. D3 comma 3. We have to show that that is a parallelogram, no? Okay. So you consider two line segments. Here gradient M1, here gradient M2 gradient. Then if M1 equal M2, lines are parallel. If M1 not equal M2, lines are inclined. If M1 times M2 equal -1, here this is somewhat special, lines are perpendicular. Then here another format, M1 equal -1 over M2. So when gradients are same, lines are parallel. When gradients different, lines are inclined. When gradient product -1, we say lines are perpendicular. While you are doing, you put this note. Somewhere you put that note. Okay, now here you see, here take AB gradient, MAB, y difference of x difference, 3 minus 1 or 1 minus 3, -1. Here MCD, 5 minus 3, 1 minus 3, -1. Therefore MAB equal MCD. Therefore AB parallel to CD. Then lines are parallel. Then AB length here 3 minus 1 square plus 1 minus 3 square root. Then 2 root 2 units. Then CD length 5 minus 3 square 1 minus 3 square root. Again 2 root 2 units. Therefore AB equals CD. Now AB parallel CD, AB equals CD. Opposite side equal and parallel, then it is a parallelogram, no? Parallelogram. Therefore say ABCD is a parallelogram. ABCD parallelogram. So these things we have done before, but anyway I am revising this because these things very important when you are doing straight lines. Put this note as well. Continue. Okay, then when you consider x-axis, y-axis, line parallel to x-axis, we say gradient 0. Line perpendicular to x-axis, we say gradient infinity. Then here corresponding inclination, theta 0, here corresponding inclination, theta 90 degree. X-axis, y-axis, take this angle theta. Here x-axis, y-axis, take this angle theta. Then here theta in between 0 to 90. Then corresponding to that gradient positive. Then here theta in between 90 to 180, then corresponding gradient negative. Corresponding gradient negative. Continue. Okay. Now further you see. Now you consider two line segment. Two line segments. Now here segments AB and CD. See this logic, huh? This is very important one. So first one, MAB not equal MCD. Then corresponding diagram will be like this. Here AB, CD. There will be intersection point, no? There will be intersection point, gradient different. Now second case, MAB equal MCD. Then corresponding case, they are parallel. Here AB, CD. Incline. Parallel, incline. So here, sometimes there can be, these two can be coincident. These two can be coincident. But anyway, usually we say parallel. Now third, here this is important. MAB equal MCD with a common point. So now let's sketch. So here you first will sketch AB, then CD parallel, no? But there's a common point. So take common point here. Then you sketch parallel line. Like this. Then we say collinear. Along in same line. That is third case. So in other words, we say if MAB equal MBC. MAB mean AB line and BC line parallel, and B is a common point, no? B is a common point. AB, BC parallel, B is a common point. Then we say A, B and ABC are collinear. A, B, C are collinear. This is very important relation. If two gradients are same, we say they are parallel. If two gradients are same, we say they are parallel. If two gradients are same with common point, we say they are collinear. Two gradient, equal gradient with common point, we say collinear. Okay, better to put that note as well. Go to question number 13, 14, 15. Question number 13. A 0,2, B 1,9, C 1,4, D -1, -10. We have to show AB and CD parallel. No? Then find MAB. 2 minus 9 over 0 minus 1. 7. CD 4 plus 10 over 1 plus 1. 14 over 2, 7. Therefore say MAB equal MCD, AB parallel to CD. Continue. 14 first one, MAB, y difference of x difference, 2 minus 1 over 1 minus 3. 1 over 2 minus half, no? MCD, 1 minus minus 1 over minus 1 minus 0. Here 2. State whether the sides AB and CD are parallel or perpendicular. Now here MAB times MCD minus half times 2, we get -1. Therefore say perpendicular. AB perpendicular to CD. So on we can do. MAB 5 plus 5 minus -1, 2 minus 1. MCD 11 minus 1, 3 minus 1. Here 10 over 2, 5. Here they are different. No? MAB not equal MCD, therefore not parallel. And similarly, according to this not type, we say MAB times MCD not equal to -1. Therefore not perpendicular. Not perpendicular. No? So on we can continue. Take time, do alone. We have to check whether gradients are same or gradient product -1 or they are not equal. So, continue. Okay, let's complete this one as soon as possible, then we can move to straight line part. You do soon. Do soon. Third, MAB 3 minus 7 over 0 minus -1, 4. -4. MCD -11 minus 15 over 5 minus 1. A -16 over 4 minus 4. MAB equal MCD. Therefore AB parallel to CD. For MAB -1 minus 8 over 0 minus 2. 9 over 2. MCD -1 minus 10 over 6 minus 2. 11 over 4. -11 over 4. Then AB not equal MCD and MAB times MCD not equal -1. Therefore not parallel or perpendicular. Parallel or perpendicular. No? Do up to question number 16. Then 15, we have to show that the points are collinear. Then let's say A 0 3, B 2 7, C -3 -3, MAB 3 -7 over 0 -2, -4 -2 2, MBC 7 -3 over 2 -3, then 10 over here 2, then MAB equal MBC, then AB BC parallel, AB parallel to BC. Since B is a common point, B is a common point, A, B, C are collinear. A, B, C are collinear. You have to check gradient there. So with common point, gradient same mean collinear. When two gradients are same, that can be parallel or collinear, no? Parallel or collinear. So here gradients are same with a common point, no? Now let's move to another section that is about section formula. Section formula. We have to practice that one as well. See. You consider here P x1 y1 Q x2 y2. Then one is midpoint. Midpoint. Usually we say x sum divided by 2. x1 plus x2 over 2, y1 plus y2 over 2 will be midpoint. Midpoint. Okay. Then there's another thing. Here general case. Here P x1 y1. We have done these things before. Here Q x2 y2. Take point R. PR to RQ M to N. Internal division. PR RQ M is to N. Internal division. Internal division. Then you write this R point here the way mx2. Here m multiply with non-related coordinate mx2 plus nx1 over m plus n. Similarly my2 plus ny1 over m plus n. Here internal division formula. Then again we have external division. Here say P x1 y1. Here you say Q x2 y2. Say R PR M QR N. Here PR is to QR. M is to N. External division. External division point. Then you write R. Same order, m multiply with non-related coordinate mx2. Here minus nx1 over m minus n. Similarly, my2 minus ny1 over m minus n. Here this is external division coordinate. Here 1, here 2, here 3. One is internal, another one is midpoint, the another one is external division. External division. Okay, just write them in that space. Page number 4. In that space you better write it. Okay, with section formula, you better remember centroid of a triangle. Centroid of a triangle. It's like this. Let's complete these things as soon as possible, then we can move to straight line. A x1 y1, B x2 y2, C x3 y3. Then here this is median, here another median, then this point we call centroid, ratio 2 to 1. So we know this one, x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. Centroid coordinate. You better put that one as well. Okay. Now let's do questions. Go to page number 5, question set 2. Page number 5, question set 2. Let's practice. Question number 19, do with me. So, find the coordinates of the midpoint. 5 plus 6 over 2 minus 1 plus 3 over 2, midpoint. 11 over 2, 1. Minus 2 plus 7 over 2, 3 plus 4 over 2. 5 over 2, 7 over 2. 4 plus 6, 7 plus 3 over 2. 5, 5. 4. 0 plus 6 over 2. 0 minus 1 over 2. 3 minus half. Continue. Question number 20. Here internal division 5, 1 and 8, 7. Here ratio 1 to 2. First point corresponds to first ratio, internal division. Here 1, 2. First point, first ratio, second point, second ratio. Then here midpoint, this point 1 times 8, 2 times 5, 1 plus 2. Again 1 times 7, 2 times 1, 1 plus 2. No? So when you find in x coordinate, you take only x coordinate. When you find in y coordinate, you take only y coordinates. 1 multiply with non-related one, 1 into 8, 2 into 5, and divide by ratio sum. Here 18 over 3, 6, 9 over 3, 3, 9 over 2, no? 9 over 3, 3, 6 comma 3. Likewise practice minus 3, 1, 1, 5. Internal division 2 to 1, first coordinate, first ratio. And here this one, 2 times 1, 1 times minus 3, 2 plus 1, 2 times 5, 1 times 1, 2 plus 1. Here minus 1 over 3, 10, 11 over 3. That is internal division. You directly apply those theorems. So when we are doing straight lines, we need to get these theorems directly. Third one, for minus 1, 0, 3, internal division 1 to 3. First coordinates, first ratio, second coordinate, second ratio. Here 1 times 0, 3 times 4, 1 plus 3. 1 times 3, 3 times minus 1, 1 plus 3. Here 3 comma 0, 4, 1 comma 1, minus 3 comma 3, ratio 3 to 1, first coordinate, first ratio, and 3 times minus 3, 1 times 1, 3 plus 1, 3 times 3, 1 times 1, 3 plus 1. Here 9, 8 over 4, 2, 9, 10 over 2, 5. Those are internal division. Identify first ratio correspond to first coordinate. Continue. Take time. Okay, then about external division, you have to find external division. So you have to do that one very carefully. Question number 21. Here first coordinate 5, 1. 5, 1, second coordinate 8, 7. So now given 1 to 2 external division. So first coordinate 1 to 2 external, no? Then first coordinate correspond to 1. Then 1 less than 2, no? 1 to 2. Then you have to extend this way. And here this is 1, then this is 2, no? And here this point you write 2 times 5, here minus 1 times 8, 2 minus 1, then 2 times 1, 1 times 7, 2 minus 1, then 10, 2, and 2, 7, minus 5. Second one, don't just write, you think and do. So I'm doing here to practice it. Then here minus 3, 1, 1, 5, 2 to 1 external division, first coordinate ratio 2, 1. Then here this point 2 times 1, 2 times 1 minus 1 times minus 3, 2 minus 1, then 2 times 5, 1 times 1, then here 5, 10, 9. Third, here 4 minus 1, 0, 3, ratio 1 to 3, then first coordinate, first ratio 1, here 1, here 3. Then here you write 3 times 0, minus, 3 times 4, no? 3 times 4, 1 times 0. 3 minus 1, 3 times minus 1, 1 times 3. 6, 0. Continue. Fourth, here 1, 1, minus 3, 3. 3 to 1 external division from first coordinate 3, no? Then you have to extend this way. 3, here 1. 3 times minus 3, minus 1 times 1. 3 minus 1, 3 times 3, 1 times 1. Here minus 9, minus 10 over 2, minus 5, 9, 8, 4. Okay, then I'll give you 5 minutes, you continue questions. I'll give you 5 minutes, just continue questions. So then we have to practice only another theorem for coordinate geometry, then later we can go for straight line section. Okay. Just continue. Okay, see this last point. So this is about area of a triangle. Area of a triangle. Take this one x1, y1. Here x2, y2. Here x3, y3. x3, y3. Then here this area we can write using coordinate geometry. Half into modulus. Here see order x1 times y2 minus y3. Plus x2 times y3 minus y1 plus x3 times y1 minus y2 here the area half into modulus x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Take that rotation order. That is area of a triangle. So if you have quadrilateral or parallelogram or whatever, that type of figures, then you can split that into triangles. Split that into triangles. Okay. Now consider here 1, 1, 2, minus 1, minus 2, 3. Let's see how to find area. Put half into modulus. X1 mean 1 times minus 1 minus 3 plus x here 2 times 3 minus 1 plus minus 2 times 1 minus minus 1. That is the order. Then 1 over 2, here minus 4, here plus 4, here minus 4, no? Then minus 4 modulus plus 4, then 2 square units. Likewise, we can find the area, okay? So, in your tutorial, page number 6, top upper space, area of a triangle. No need to prove, just write this relation and you do question number 30. Question number 30. Question number 30, first one. Half into modulus 1 times 2 minus minus 1 plus 3 times minus 1 plus 0 times 1 minus 2 modulus. Now you simplify. Here 3 minus 6, 3 over 2 square units. Half into modulus 0 times 2 minus 0 plus 9 times 0 minus minus 1 plus 10 times minus 1 minus 2. Then 1 over 2, here 0, here 9, here minus 30, 21 over 2 square units. Here application of this modulus, that is about neglecting sign. Then if you have minus sign inside, you forget that sign, convert that into plus. But if you have plus sign, you can forget modulus. That's the application of modulus. Okay, here minus 3 over 2. Okay, third one. Half into modulus 3 times 9 minus 6 plus 1 times 6 minus 2 minus 1 times 2 minus 9. You take one circular order, first coordinate, second coordinate, third coordinate. Likewise, you get circular cyclic order and write the pattern. 9, 6, 3, 9, 6, 2, 4, 9, 4, minus 7, plus 7. Here 9, 4, 13, 20, 10. Area, we write by square units now. So if we have quadrilateral, you have to sketch it properly, then split into two triangles. Split into two triangles and add them together area. Area you have to add. Okay, do up to that. You do question number 31. 31 quadrilateral given on xy plane or xy plane, you mark each coordinate. Okay. Thereafter identify quadrilateral and split into two triangles and add them together. Okay, I'll give you 1-2 minutes to complete it. Do it. Okay, then that's enough for coordinate geometry. That's enough for coordinate geometry. Okay. Now just see. So now we can move to straight lines and straight line part. Before that, we have to think about locus. Okay, see. You consider here a variable point p x comma y. So let's say it varies. Here this is we call locus of a variable point p. So here there can be different type locus, straight lines, circles, straight line, circle, an ellipse, and parabola, hyperbola. Likewise, there are different types locus. So here we are going to discuss mainly about straight lines and circles only. Straight lines and circles only. But anyway, when finding locus, we have one technique. Okay. You have space, no? Locus of a variable point. Okay, just write somewhere there. Just write. Let a variable point p, let a variable point p which varies with a certain geometrical condition. Therefore, when finding locus, follow the following steps. When finding locus, follow the following steps. Step number 1. Take the variable point p as x bar comma y bar. Step number 1. Take the variable point p as x bar comma y bar. Take the variable point p x bar comma y bar. Step 2. Create a relation with x bar and y bar. Create a relation with x bar and y bar. Create a relation with x bar and y bar as according to the given geometrical condition. As according to the given geometrical condition. Given geometrical condition. Okay. Step number 3. Remove all unknowns. And replace x bar by x and y bar by y. And replace x bar by x and y bar by y. Okay, you just put this note as well there. Okay. Now see, locus of a variable point. See this technique. So I told you here, we have to think about variable point first. You take that variable point as x bar, y bar. Take that variable point x bar, y bar first. Okay. Now, consider, write down this question, write down. Find locus of the variable point P. Find locus of the variable point P where it varies, find locus of a variable point P where it varies one unit length from the origin. Okay, see here x-axis, y-axis, see this procedure. Here you take point P, here length given 1 unit. we take x bar y bar, you take p x bar y bar, okay. Then here x bar, here y bar, here this length given, you have to create a relation. You have to create a relation with x bar y bar. Now here we can apply Pythagorean theorem now. Then x bar square plus y bar square equal 1 square. So I told you when we are finding locus, we have to take one point, that variable point as x bar y bar. Okay. Thereafter, according to given geometrical condition, we have to create a relation. So here x bar y bar now. Then apply Pythagorean theorem to connect this one. Then we don't have any other unknowns. You have to think x bar y bar known now. So no any other unknowns. Later you have to substitute x bar as x, y bar as y. Then that will be the locus. Then you replace x bar by x, y bar by y. Then x squared plus y square equal 1. Here the locus. At the locus, okay. So anyway, this is a circle, but don't worry about that identification. Later we will see how to identify circle equation. Okay. For now, you just try to obtain equation of the locus. That's enough. Do that. Okay. Now second one, find the locus of the variable point P. Find the locus of the variable point P, where AP equal BP. AP equal BP such that A1, 1, B2, minus 1. A1, 1, B2, minus 1. Okay, see. Now here point A 1, 1. Point B 2, minus 1. Take P here. Say x bar y bar. Then AP equal BP, no? AP equal BP. Then AP length x bar minus 1 square plus y bar minus 1 square root, distance between 2 points. Then BP equal x bar minus 2 square, y bar minus 1 and y bar plus 1 square root. No? Distance formula x difference square plus y difference square root. No? Then simplify this one, square both sides and simplify. And later you substitute x bar equal x, y bar equal y. Then x square minus 2x plus 1, y square minus 2y plus 1, x square minus 4x plus 4, y square plus 2y plus 1. Now simplify this. Here 2x minus 4y minus 3, 0. Here the equation. Continue. Okay, now third one. Third one, find locus of the variable point P. Find locus of the variable point P where the distance from A 1 comma 2, where the distance from A 1 comma 2 is 3 units. 3 units. Okay, you try. Okay, see, take P x bar y bar, then AP distance equal 3 now. Then x bar minus 1 square, y bar minus 2 square root is the distance now, equal 3. Now square both sides and simplify. And replace x bar by x, y bar by y. Y bar by y. Usually we consider P mean variable point now, but we consider only one general point to derive that expression. So that general point we take x bar y bar. Later we have to variate it. Then to variate we take x bar as x and y bar as y. Okay. Then if you put x bar as x directly, then we get same equation, but that not that much good. Okay, then here x squared plus minus 2x plus 1, y square minus 4y plus 4 equal 9. Then x squared plus y square minus 2x minus 4y minus 50, na? Minus 40. Here the locus. So anyway, later we need to identify different forms of the locus. Here the locus now. Okay. Now with that one, so we have especially conic sections. Now see, you consider here a cone, here a cone. So coordinate geometry mainly deals with geometry, no? Geometry. So when you consider this cone here, this is a point. And here a circle. And here edge a line. When you get cross section here, then here this one we say an ellipse. An ellipse. So when you consider another cross section like this, we see here a parabola. Parabola. So if we section here this way, we see hyperbola. But don't worry about those. Those are we call conic sections. Conic sections, but mainly we focus about straight line and circle. Straight line and circle. You just remember here ax plus by plus c format. Here straight line. Straight line. Ax plus by plus c format we call a straight line. So here we don't have any xy term. We have only x to the power 1, y to the power 1 relation only, no? X to the power 1, y to the power 1 relation, no xy term. We call that is straight line. Then equation like x squared plus y squared plus 2gx plus 2fy plus c equals 0. Here x to the power 2, y to the power 2, coefficient same, no xy term. Coefficient same. We call it is a circle. Circle. Then y equal ax squared plus bx plus c. Here this is quadratic format, no? Quadratic format. This is called parabolic shape. Parabola. Parabola. These are just basic equations, huh? But there are different forms. Here the basic one. Then x squared over a squared plus y squared over b squared equal 1 type. We call ellipse. Then x squared over a squared minus y squared over b squared we say hyperbola. Hyperbola. Those are conic sections. So anyway, just remember these type of equation may see in future. Usually we consider about straight line and circle. We discuss everything under straight line and circles, not the others. But parabolic thing under quadratic function we have discussed that. y equal x square, parabolic shape graph, y equal minus x square, parabolic shape graph. Then under quadratic we discuss about parabola, but the other part we don't discuss in our A levels. Later we will discuss that. So anyway, you identify there are different conic sections. These are conic sections. Each conic section has different formula patterns. So you just identify there are some different patterns. That's it. Okay, put that note as well. Somewhere you can put that one. Huh? Okay. Now let's move to straight line equations. Okay. Now that is about locus of a variable point. Now we can move to page number 7, difference form of straight lines. Okay, now you see. So under this straight line lesson, we mainly focus about different forms of straight line equations. As an example, y equal mx plus c, ax plus by plus c equal 0, x over a plus y over b equal 1, x cos alpha plus y sin alpha equal p. Then x minus alpha, y minus alpha, m times x minus alpha, y minus y1 equal y2 minus y1 over x2 minus x1, x minus x1. Here these are different forms of straight lines. So under O levels we discuss only about y equal mx plus c, y equal mx plus b. But there are many other forms. So we call m gradient c intercept, no? C intercept. So you consider here x-axis, y-axis, you consider a line. I'll sketch a line like this. Here we call straight line. So here when you consider this angle theta, we call theta slope. And tan theta we call slope or inclination. Then tan theta we call gradient, m. Gradient. Then here this point we call say B, here say A. Then B we call y-intercept. And here A we call x-intercept. And further we have another one special thing. Here take this one angle theta. So we can sketch perpendicular line from the origin. Here you take here P, and take this angle alpha. Here P we call perpendicular distance from the origin. Okay, likewise there are, when we consider a straight line, there are some properties like that. Okay, so those properties are slope, gradient, x-intercept, y-intercept, perpendicular from the origin, and those are the properties. So with those properties we can create different equations. Here y equal mx plus c, ax plus by plus c, x over a plus y over b equal 1, x cos alpha y sin alpha equal p. Likewise there are different forms. So you just identify m in gradient. You just identify AB, usually AB as x-intercept, y-intercept. But here AB is somewhat different. This AB is somewhat different. M as gradient. Likewise, you generally identify. Then according to this data set, we can create equations using that locus technique. Okay, we're going to do that one. Okay, you just write these different in that space, page number 7. In that space, you better write this different forms. 1, 2, 3, 4, 5, 6. Okay, now let's derive them. Then later we can apply all of them directly. Okay, you need to remember this pattern directly with corresponding data set. Then thereafter we can apply these equations directly. Okay. Okay, now you better to go to new page. Yeah? Within that space we can't write. You can go to your notebook. Okay, now here slope intercept form. Slope intercept form. Okay, see here this case, take x-axis, y-axis. Here when you consider this intercept will be given and gradient will be given. Gradient will be given. Slope given mean gradient given. I'm going to find this equation. Okay. Now when finding equation, I told you, so here point varies now. Locus mean the tracing path. Here you take general point P as x bar y bar. We're going to find locus. Okay. Take general point P, x bar y bar. Now here this point intercept no. Then we write here 0, c no. Then gradient given, intercept given, you have to connect these three. So now we can write gradient m as y difference of x difference, y bar minus c of x bar minus 0. When you have 2 points, we can write gradient. No? Y difference of x difference is the gradient. Now cross multiply mx bar y bar minus c, y bar equal mx bar plus c. Now you take x bar as x, y bar as y. Then finally y equal mx plus c is the equation. You can take this formula directly. If you know gradient and y-intercept, you can directly write this one as like this. Take m, y-intercept, m1 gradient, y-intercept 2. Say y equal mx plus c. Okay, take y equal mx plus c. Then y equal 1 times x plus 2 likewise. Minus 2 intercept 1. Y equal minus 2x plus 1. Then here gradient half and here y-intercept minus 3. Then y equal half x minus 3. So on. 1/3 minus 1/3 gradient 1. Say y equal 1 over minus 1/3 x plus 1. So on. We can write directly formula. No? Okay. First prove this formula and write some examples. Here this one just only minus 1/3. Just only minus 1/3. Then take 0, 0 here intercept 2. Y equal 0x plus 2. Then that is y equal 2. Write them soon. Okay. Now you just remember this formula. Just remember this formula directly. You can apply them directly. But that one, the proof. Okay. So see another one. Next one, point slope form. Point slope form. Here point on this line given a comma b and one gradient, its gradient given m. These two data given. Point on the line given and gradient given. So you can do this, say you take point P, x bar, y bar first. Then gradient mean y difference of x difference. Then m equal y bar minus b, x bar minus b, x bar minus a. Here we are finding locus. No? So I told you when finding locus, you better to get one point, general point x bar, y bar. Thereafter you connect all. Connect all. Then later you substitute, replace x by x and y by y. No? Then y bar minus b equal m times x bar minus a. Now replace x bar by x, y bar by y. Then y minus b equal m times x minus a. Here the corresponding equation. So now take gradient m, point on the line 1, 1, 2, 2, minus 1, 3, 1 over 2, minus 1, minus 4, 5, 1, 5, 0, 1, 1, infinity 2, 1. Here somewhat special gradient infinity case. Now see here y minus 2, m mean 1, x minus 1. No? Then here y minus 3, gradient mean 2, x minus minus 1. We get x plus 1. No? Minus minus 1. Then here y minus minus 4, m mean half, x minus minus 1. Here y minus 5, 5 times x minus 1. Here y minus 1, 0 times x minus 1. Here y minus 1, infinite times x minus 2. But here somewhat special. You better write y minus 1 over x minus 2 infinity. Then we get infinity when x minus 2 equals 0. No? When x minus 2 equals 0. Okay. Then you can write here x minus 2 equals 0. Denominator 0 result will be infinity. No? Then x minus 2 equals 0 will be the equation. Okay, do it. Okay. Then see, next one 2-point form. See 2-point form. Now here this case 2 points are given. Here x1, y1, x2, y2. Here these 2 points are given. You take here A, here B, and take general point P, say x bar, y bar. Now we have to connect them, no? By these two find gradient, by these two write gradient, and equate them. Y bar minus y1 of x bar minus x1 equal y2 minus y1 over x2 minus x1. Now cross multiply and replace x bar by x, y bar by y. Y minus y1, y2 minus y1, x2 minus x1 times x minus x1. Here it is. Okay. See example 1, 1, 2, 3, 5. Take this. Then here you first should take this y minus 2 over x minus 1, and by these two find right gradient again. 5 minus 2 over 3 minus 1. 5 minus 2 over 3 minus 1. Now simplify. You can simplify, cross multiply. Y minus 2, here 2, here 3, 3 over 2 x minus 1. Later we will see general form, but anyway you identify how to just write that equation, that's enough. Okay. Okay, write this 2-point form, take this and you write 1 minus 1, 2, 3, 1, 2, 5, 1 minus 1, minus 1, 2, 3, 4, 2 minus 1, 3 minus 2. Continue. You better to simplify this, Anna. 2y minus 4, 3x minus 3, then 3x minus 2y plus 1, 0. 3x minus 2y plus 1, 0. Here it is 3x minus 2y plus 1, 0. You better to convert up to that. Take time, do alone. Okay. Check your answers. Check your answers. Y difference of x difference. Here, first take this coordinate. Y minus 2 of x minus 1. 2 minus 1 over 1 minus 3. Here y minus 5 over x minus 2, 5 plus 1, 2 minus 1. Y minus 2 over x plus 1, 2 minus 4, minus 1, minus 3. Y plus 1, x minus 2, minus 1 plus 2, 2 minus 3. Now later you simplify. Okay. Now next type, intercept form. Intercept form. Now here this case, x-intercept, y-intercept given. Here y-intercept say b, x-intercept say a. No any other data given, only x-intercept, y-intercept given. So that means 2 points are given now. 2 points are given. Then like previous case, 2-point form we can write it now. Then you take point P here, x bar, y bar. Then by this write y bar minus 0, x bar minus a. B minus 0, b minus 0 over 0 minus a. Now simplify. Take x bar as x, y bar as y, minus ay, bx minus ab. Now simplify. Bx plus ay equal ab. Then to remember this pattern, we do this thing. X over a plus y over b equal 1. X intercept a, y intercept b. X over a plus y over b equal 1. So example, x intercept, y intercept 1, 2. You write x over 1, y over 2 equal 1. Likewise, you can directly write 3 minus 1, x over 3, y over minus 1, 1. 4 minus 2, x over 4, y over minus 2, 1. So on we can write. Okay. Do this proof. We have done 4 different forms. We have done 4 different forms. Okay, there's another form, normal form. Normal form. Here the given data, perpendicular distance from the origin to the line P given, and that perpendicular make angle alpha with the positive direction of the x-axis, anticlockwise sense. Then we're going to find this equation. You take point here x bar y bar. See this carefully. Here see this figure. Here perpendicular length P, angle alpha. Then here point x bar y bar. Then here coordinate x bar. Here this length P cos alpha. Then here balance x bar minus P cos alpha. Here P sin alpha. Then coordinate here y bar. Then here this length y bar P sin alpha. Sorry, y bar is here, no? Then P sin alpha minus y bar. Then alpha 90 minus alpha, here alpha. Here this angle alpha. Then we can connect now. Tan alpha equal, here this length x bar minus P cos alpha. X bar minus P cos alpha, here P sin alpha minus y bar. Then here sin alpha over cos alpha, x bar minus P cos alpha, P sin alpha minus y bar. Then cross multiply. P sin squared alpha, y bar sin alpha, x bar cos alpha, P cos squared alpha. Then x bar cos alpha plus y bar sin alpha. Then take P cos alpha the other side. Cos square alpha plus sin squared alpha. We know cos squared plus sin square 1, no? Trigonometry. Then later you take x bar as x, y bar as y, then x cos alpha plus y sin alpha equal to P now, no? So you remember that equation directly. Here perpendicular length from the origin P, that perpendicular make angle alpha with the positive direction of the x-axis, anticlockwise sense. So for that data we can write that formula. See some examples. See here P and alpha. 1 30 degree, 4 45 degree, 2 60 degree, 1 135 degree. Then write here x cos 30 plus y sin 30 equal P. X cos 45, y sin 45 equal 4. X cos 60, y sin 60 equal 1. X cos 135, y sin 135 equal 1. So on we can write. You can directly apply formula and you better remember this one. This is not usually no application this type of term generally, but you need to remember that one. Okay, put it. Okay. Now let's see final versions. We have done everything now. Now I gave that one. No? Y equal mx plus c. Y equal, sorry, yeah, y minus y1 equal m times x minus x1. Then y minus y2, y minus y1, y2 minus y1 over x2 minus x1, x minus x1. Then x over a plus y over b equal 1. And then x cos alpha plus y sin alpha equal p. So here slope intercept form, here point slope form, here 2-point form, here intercept form, and here normal form. Normal form. So when you think about these equations, all are x to the power 1 relations, no? Y to the power 1 relation. All are x to the power 1, y to the power 1 relation. We can't see any xy term, x into y, xy term we can't see, no? No minus powers, irrational powers, or further power 2, power 3, so on. So we have power 1. Then here no xy terms. Okay, x to the power 1, y to the power 1 term contained. Contains. That means linear, we call linear. Therefore, general form, by considering all together, we can say general form as ax plus by plus c equals 0. Here the general form, here onwards we write x to the power 1, y to the power 1, no xy term. Then by considering all, we can compact that into form ax plus by plus c equals 0. Ax plus by plus c equals 0. Here this one we can get reversed into each format. Okay. Anyway, this is general form. Better write that one as well. Then you come to page number 7, question number 33. Page number 7, question number 33. All the things I have done now. you do them. No need to prove, you can just write equations. Huh? You can just write equations, 33 only. Okay, time's enough. Check your answers. First one, gradient 3 passing through 2, 4. Y minus 4, 3 times x minus 2. Simplify. 3x minus y minus 2, 0. Better write general form now. Gradient minus 2 passing through point 0 minus 3. Y plus 3 minus 2 times x minus 0. 2x plus y plus 3, 0. Y plus 3, x plus 2, 5 plus 3, 2 plus 2. Simplify. Y plus 3, 2 times x plus 2. 2x minus y plus 1, 0. 4. Y minus 4, x minus 3. 4 plus 2, 3 minus 2. Y minus 4, 6 times x minus 3. Here 6x minus y (14), 0. 4, 5. Intercept 2, gradient 3. Y equal 3x plus 2. Intercept minus 3, gradient half. Half minus half x minus 3. 7. Intercept 1. Intercept 4 and minus 1. X over 4. Y over minus 1 equal 1. 8. X over 2. Y over 1/5 equal 1. Then 9th one, perpendicular distance 5 units, angle 45. X cos 45 plus y sin 45 equal 5. 10 x cos 135 y sin 135. Later you simplify, yeah? Equal 4. Straight line parallel to x-axis. Straight line parallel to x-axis means gradient 0. So indirectly gradient has given, no? Then 11th one, point y minus 3 gradient 0 times x minus 0. 12th one, parallel to y-axis. Then y minus 0, x plus 2, parallel to y-axis means gradient infinity. So infinity means denominator 0, you have to take. Then x plus 2, 0, that is somewhat special. Huh? Infinity gradient thing, special. Okay. Now you see different conversions by general form. Consider ax plus by plus c equals 0. So here first conversion, bx plus bx equal by equal minus ax minus c, then subject y, minus a over b x minus c over b. Then this is y equal mx plus c format. Then here we call gradient, and here we call y-intercept. Likewise, we can convert general form. Then see another conversion. Ax plus by equal minus c. Then divide by minus c. Ax over minus c, by over minus c equal 1. No? Then take a to downstairs, x over minus c over a, y over minus c over b. Here intercept form, no? Intercept form. Then you can say here x-intercept and y-intercept. Here x-intercept and here y-intercept. Okay, x-intercept and y-intercept. Okay, see. Now next, ax plus by equal minus c. Now take here a, b, a square plus b square root. Then divide by this one. Then you take here alpha, then we say x cos alpha. Cos alpha x sin alpha y minus c over a square plus b square root. Here you say p here. Then x cos alpha plus y sin alpha equal p. Here we can convert different forms. General form we can convert to here slope intercept form, here just intercept form, and here normal form. All the other cases are same. 2-point form, point slope form, those are similar type. But we have to remember how to convert general form to this special trick thing. Then here this one we say perpendicular distance minus c over a square plus b square root. Okay, just write that conversions. Okay, now you just try by these type of relations. Question number 34. Try question number 4. Using equation, we have to obtain x-intercept, y-intercept, gradient, and so on. Okay, question number 34. Do it. Okay, that's enough. That's enough for today. So anyway, you try to complete questions up to question number 36. Question number 36. Up to question number 36. Coordinate geometry part you can complete now. Then complete that one as well. And up to question number 36 you do. And next we have to discuss straight lines and point relations, straight line and 2-point relation and 2 straight line relations. Next day we can complete that one. Okay, that's enough for today.